For example C, I'm going to put everything on one side of the equation before I start completing the square. I'm going to say that in this case, 1 over 3 x squared plus 3x minus 9 is equal to 0. 1 over 3 x squared plus 9x minus 9 is equal to 0. 1 over 3 x squared plus 9x plus, in this case it would be 9 over 2 squared, is going to give me 81 over 4 minus 81 over 4 minus 9 is equal to 0. 1 over 3 x squared plus 9x plus 81 over 4 minus 9 and minus 81 over 12 is equal to 0. Remembering that the 9 is going to have to go over 12 to combine these as well, which means that this would be actually 108 over 12 if I want to do it that way, or I can simplify the 81 over 12. In this case, I can divide the top and the bottom both by 3. If I divide the top and the bottom by 3, then I'm going to get 27 over 4, and the 9 can now actually become 36 over 4. So I have 1 over 3 x plus 9 over 2 squared minus, when I combine these two things, it's going to give me 63 over 4 is equal to 0. One over 3 x plus 9 over 2 squared is going to equal 63 over 4. Divide both sides by 1/3, and I get x plus 9 over 2 squared is equal to 189 over 4. X plus 9 over 2 is equal to the positive or negative square root of 189 over 4. Well, I can simplify this one by just taking the square root of the top and the square root of the bottom separately. And I'm going to say that it's going to be plus or minus the square root of 189, and the square root of the bottom is just going to be 2. That makes it easier for when I'm combining these terms, which means that x is actually going to equal negative 9 plus or minus the square root of 189, and it's actually all over 2. For example D, I'm going to start the exact same way. I'm going to divide the 4 out of the first two terms, x squared minus 6x, and then plus 47 is equal to 0. 4 bracket x squared minus 6x plus 9 minus 9 plus 47 is equal to 0. 4 x squared minus 6x plus 9 plus 47 minus 36 is equal to 0, or 4x squared, sorry, I'm going to take the square root of this, x minus 3 squared plus 11 is equal to 0. And then I'm going to start solving this for x minus 3 squared is equal to negative 11. X minus 3 squared is equal to negative 11 over 4. And x minus 3 is going to equal the positive or negative square root of negative 11 over 4. Can't take the square root of a negative, which means that there is no solution. For example 5, we're going to solve this equation by completing the square and then express the answers to the nearest hundredth. So I have 1 over 4 x squared plus x, and then when I move that 1 over 8 across, it's going to be plus 1 over 8 is equal to 0. One over 4 x squared plus 4x plus 1 over 8 is equal to 0. 1 over 4 x squared plus 4x plus 4 minus 4 plus 1 over 8 is equal to 0. 1 over 4 x squared plus 4x plus 4 plus 1 over 8, and then it would be minus 1, but I'm going to write it as minus 8 over 8, so I can combine my final terms, is equal to 0. 1 over 4 x plus 2 squared is going to equal, minus 7 over 8 is equal to 0. Now we're going to go through the process of solving it. So we're going to first move that 7 over 8 across. 1 over 4 bracket x plus 2 squared is going to equal positive 7 over 8. Or, when I divide both sides by 1/4, x plus 2 squared is going to equal positive 7 over 2. X plus 2 is going to equal the positive or negative square root of 7 over 2. Which means that I'm going to split it into the two possibilities. X plus 2 is equal to positive square root of 7 over 2. Or x plus 2 is equal to the negative square root of 7 over 2. This means that x is going to equal negative 2 plus root 7 over 2. And this side is going to mean that x is equal to negative 2 minus root 7 over 2. This, to the nearest hundredth, is going to be x is equal to negative 0.13. This is going to be x is equal to negative 3.87. For example 6, the length and width of a rectangle are 6 meters and 4 meters. When each dimension is increased by the same amount, the area of the new rectangle is 50 meters squared. Determine the dimensions of the new rectangle to the nearest tenth of a meter. Well, if I'm increasing each of them by the same amount, then that means that the length would now become 6 plus x, and the width is going to become 4 plus x. And this is going to give me an area of 50. So I can state that in this case, when I multiply this out, I'm going to get x squared plus 10x plus 24 is equal to 50, or x squared plus 10x, when I move that 50 over, minus 26 is equal to 0. Now I can complete the square. I'm going to bracket this off and say that it's going to become x squared plus 10x plus 25 minus 25 minus 26 is equal to 0. X squared plus 10x plus 25 minus 26 minus 25 is equal to 0, or x plus 5 squared minus 51 is equal to 0. X plus 5 squared is going to equal 51, and x plus 5 is going to equal either the positive or negative square root of 51. Well, if I said it was the positive one, then x plus 5 is going to equal the positive square root of 51. If I said it was the negative, it's going to be x plus 5 is equal to the negative square root of 51. X would equal negative 5 plus the square root of 51, or x would equal negative 5 minus the square root of 51. One side, because I'm going to solve what they are to the nearest tenth of a meter, one side is going to give me the possibility that x will actually equal 2.1, and let's say 14. The other side is going to give me x is equal to negative 12.14. This answer doesn't make sense given my problem because I'm not going to have a negative side length. So really, I'm just looking at this 2.14. Well, if that is the case, then to the nearest tenth of a meter, I'm just going to take my 6 and add 2.1 to it, or my 4 and add 2.1 to it. The new dimensions are 8.1 meters by 6.1 meters to the nearest tenth.